Let's jump right into this explainer. Today, we're strapping in and, well, putting on our detective hats for a high-stakes digital mystery. We're going to walk through a classic, everyday scenario that honestly plagues databases everywhere. You know those issues that quietly eat up system resources and drag your applications down until everything just grinds to a halt? Yeah, those. We'll look at the clues, trace the performance killers, and figure out exactly how to solve a fundamental database design issue. If you work with data at all, this is a journey you absolutely need to take.
So picture this. You've just landed a great new gig as the newly hired database administrator at AdventureWorks. It's a solid 10-year-old bicycle and parts company selling directly to consumers. But they're right in the middle of a major digital transformation project, and things under the hood are a little, well, they're messy. Your core mission? Proactively hunt down query performance issues and nip them in the bud before they completely crash the system. No pressure, right? You're stepping into a mature environment, which basically means you're inheriting a decade of someone else's code and, frankly, their design choices.
Okay, let's dive into this. As you start reviewing the system, you spot this seemingly innocent query. It's just a basic select statement, right? It's pulling some standard fields, business entity ID, login ID, hire date, job title, straight from the HumanResources.Employee table. And it's just looking for one specific employee where the national ID number equals 144178007. At first glance, this is SQL 101. It looks perfectly fine. But as an experienced DBA, you know looks can be super deceiving. You never just trust a query by glancing at the syntax.
So you decide to actually test it. You fire up SQL Server Management Studio, paste the query in, but right before you hit execute, you make an absolutely crucial move. You turn on the actual execution plan, or, just hit CTRL+M if you like keyboard shortcuts. The query runs, the results pop up, but when you tab over to the execution plan, you see it, the warning sign. Right there on the very first select operator is this glaring yellow triangle with an exclamation point inside. In the database world, that yellow triangle is essentially the system waving a giant red flag, practically begging for your attention.
When you hover over that little yellow warning, the system gives you a very specific diagnosis: implicit conversion. But what does that actually mean? Well, think of the SQL Server Query Optimizer as a brilliantly efficient detective trying to map out the absolute fastest route to your data. An implicit conversion happens when that detective is handed bad evidence, specifically a mismatch in data types. To make the query work, the optimizer is forced to pause, do a bunch of extra work, and literally translate one data type into another on the fly before it can even start searching. This completely forces the system to abandon its fast routes. It creates suboptimal execution plans and generates completely unnecessary performance overhead.
Now, what's really interesting about this is exactly where that mismatch lives. To find it, we've got to pull up the table's structural blueprint, its data definition language. Check out the second column defined here, national ID number. It's actually structured as an NVARCHAR 15, which is a string of characters. But remember our query? We asked it to search for national ID number equals 144178007, typed out as a raw number. We handed the database an integer, but the table was built to hold text. Because of this tiny, seemingly harmless inconsistency, the optimizer is forced to implicitly convert that number into an NVARCHAR value for every single row it checks.
So let's look at the fastest, most immediate fix, just changing the code. Notice the comparison here. On the left, we've got our original problematic code passing an integer. On the right, we've simply wrapped that number in two single quotes. Honestly, that's it. Those little single quotes change the parameter from a number directly to a character string. Now the value we're passing perfectly matches the NVN of our data type of the column. If you run this updated query, that yellow warning triangle completely disappears. The optimizer is thrilled, the overhead is gone, and your execution plan is optimal again.
But as the new DBA, you might be sitting there thinking, wait a second, a national ID number really should just be a number, right? Why on earth was it set up as an NVARCHAR in the first place? Fixing the code is, well, it's kind of just a band-aid. What if we want to tackle the root cause? What happens if we decide to take path B, roll up our sleeves, and alter the actual table structure to make that column an integer data type, so nobody ever has to worry about adding single quotes again?
So you write up a quick alter table command to change the column to an INT. You confidently hit execute, and boom! You are immediately slapped with this aggressive red error text. Message 5074. The index AK_employee_national ID number is dependent on column national ID number.
And right beneath that, it flat out tells you the alter table command has failed. You see, you can't just forcefully change a column's data type when it's actively holding up the infrastructure. That column is part of an existing non-clustered index. It is literally woven into the very fabric of how the database searches.
Let's move to and see how this builds, because if we actually commit to this path, we have to perform what I like to call database surgery. It's intense. First, we have to completely drop the existing index that relies on that column. Then, once the column is finally free from the index, step 2 is running our alter table command to actually change the data type from NVChar to int. And finally, step 3, we have to entirely recreate and rebuild that unique non-clustered index from scratch.
Now, sure, if we check the execution plan after doing all this surgery, the implicit conversion is gone. But look at the massive consequences of this approach. Doing this in a live production environment, that means extended downtime and probably a few panicked phone calls from your boss when things suddenly break. Plus, dropping and rebuilding indexes on huge tables takes massive computing power and locks the table up. But wait, it gets worse. You inherited a 10-year-old system. There are likely dozens of other applications, reports, and random queries out there that completely rely on that column being an NVARCHAR. By changing it to an int at the base level, you risk breaking all of those downstream dependencies at the exact same time.
And this brilliantly illustrates a really fundamental lesson of database administration. Choosing the right data type during the initial design phase is absolutely critical, simply because changing it later is a total nightmare. In our AdventureWorks case, a simple set of single quotes saved the company from hours of production downtime and massive cascading errors. It's a powerful reminder that sometimes the biggest performance killers are just tiny little inconsistencies hiding right there in the query window. So I'll leave you with this. Are there implicit conversions hiding in plain sight in your databases right now? It might just be time to hit CTRL+M and find out. Thanks for joining me on this explainer, and hey, happy hunting.
Hey everyone, yeah. In this section of lab, we'll go through DP-300 database administrator, and lab is identify database design issues. So still we are in progressing with database performance related issues, and this time we'll find what the issues and how we can resolve that one. So the technique. I will share this GitHub link so that you can follow when you do into your own environment, and make sure that you downloaded all the required files beforehand, so that you can follow this lab. So this lab is mainly focusing that how to identify when you're running any query, and what actually is causing the problems. In this case, that is related to implicit data type conversion, and we will go through how to fix it to improve the query plan. So let me go to that management studio. So when you see the page for connect to the server, so connect to the server that you have got. In my case, I am fine with this the server for my lab purpose. But you can create a SQL managed server where actually install your database. So you can select based on that, and also the authentication type you set that up. Click trust server certificate and then click on connect. So then here select the databases options folder. Then you can click right click and you can see the different options are available here. So I'm going to execute a query. So select on new query. When that new query tab open, copy the SQL from the lab files or lab documents. So the very first one is just to restoring the database using the backup file, and it will create a database, and also it will do two files, like one is database related files, another is log related files. And let's, after that, when you do that one, then execute that command. And you see that all those files are restoring. And when that done, you can see that that's completed and query executed successfully. So now, if I refresh this one, you can see this database is there now. Next, open a new tab, and copy the SQL to execute a query. So use that database. Then we are doing a SQL statement that select all these columns from there, and this is we are putting a conditions based on this ID. Then execute that one. So you can see that query executed successfully. And we would like to see the execution plan for this SQL or T-SQL. So here you see the options that include actual execution plan or control M. So select that one. And now you execute the query. So you can see that now execution plan is popping up here. So you can see that panel. Let me put that little up. And if you see here, the select statement has got some yellow triangle here. This indicates actually that there is a warning message associated with the operator. So when you hop over there, it just giving all the message details. So warning message actually indicate that there is a implicit conversion in the query. Oh, if I move that, then I cannot. No. Okay, so you can see the down that warning section. It's giving that there is an implicit conversion in the query. This means that the SQL Server query optimizer had to convert the data type of one of the columns in the query to another data type. So that is the issue here. Now we will see that how to fix the warning message. So let me open a new tab, new query window, and copy paste the command. So here you see that the table is defined. Here we can see the data definition language statement, and going to review all the fields used for the previous SQL that we executed. So if we do that one, there are already an object name employee. So create table, this one. So this is the definition. Now, if we go back here, definition in the sense like this table has got all these columns and the data type and not null. That means you have to pass values. Then you can see that it has got NVARCHAR or integer, small integer. So different types, it's actually showing the data types one. So now if you go back here, so it is querying business entity ID, national number, login, hire date and job title. And now we are giving national ID number. We are giving a number. Okay, so we are comparing that one. So national ID number, if we go there, we are using number, but if you see here, we can see that NVARCHAR data type. So which is not a integer data type. This is the inconsistency which is causing the database optimizer to implicitly convert when we are querying this one, it's implicitly convert that as a number type. So this is actually causing overhead for the query performance. So for a small like here with data, we are not getting, we cannot see the time it is actually taking. But if you think that there is a millions of rows, and then it will be a big query cost. But in the system, even for this testing purpose, it's showing that there is a query cost. And what the what for this one, if you see the warning message, then you will get to know. So now how can we change the code? So for that, to resolve the implicit conversion, we need to change the code and rerun the query. So what can we do? For that, let me go back to like if we go here, there is an option, one thing we can do, like we can put a code. So if we put code between, that may resolve the issue. So let me execute this query now. If you go to execution plan, you can see that yellow sign, we cannot see that one anymore. So that fixed actually issue, that warning message no longer there. So what does that mean? That we have to continuously, whenever we call this column, we have to use that code so that it knows it's like act as a NVARCHAR type. So to fix this issue, like data type conversion, what we can do, we can convert the table structure. So to attempt the fixed index, let's open a new query window and type the command. So what we are doing, that we are in that table, we are just giving that alter table, then alter column is not null. So let me execute that one. So when you are trying to change that one, you can see that the index is dependent on column. So you are getting a message because this column is already existing non-cluster index. So when we do this one, so that means we have to rebuild those indexes also, resolve the issue. So for that, let me open a new query window where we'll go like rebuild those indexes. So what we are doing first, remove the dropping the index so that we don't get that message. Then we are changing the column data type to resolve the issue that we are getting, and then we'll recreate the index. So these three tasks. So let me execute that one. So that completed successfully this time. So let me query, execute the query again. Okay, better let me open a new query window and paste the query. So we are not getting any error message this time. And if we go back the query that first that failed or not failed actually, we got the message, very first one. Let me move this code, and that is still enabled. That execution plan, would like to see what is happening and execute this time and go to execution plan. You see that we are not that kind of notification. So it is using the most optimal, if I say, the execution plan. So that's it for this lab. If you have any questions, you can add that into comment section. Otherwise, see you into next lab.